Okay, hi guys. Okay, so welcome back for the example video. I know some of you might get confused on the theory video. That's just a theory, but I will do my best. Okay, as usual, we will just go through example. Okay, so for example, since example, I'll just repeat something because some people might not interested in the theory. They want to skip the theory and just know how to do it only. Okay, so for an example, I'll focus on example 19. I'll try to zoom it if possible. Okay. See, I can zoom or not. Okay, I can't zoom. Oh, it went off already. Okay, so I managed to zoom already. Okay. So in the example, okay, they give you. I won't do all. I'll do few only. So they gave you a curve there. They give you a curve there. Then they said the area is from 2 to 3, and they say this equation of this curve is y equals to x squared. Okay. So they're asking you to find the area of the shaded region. So like I mentioned the theory video, area of shaded region means from this curve up to the x only. We're not looking anything beyond than that. So for area of curve, you have learned before. Keyword, remember when you see a curve and an equation, they ask you to find area, you know already you have to do integration. That's the keyword for you. Okay. So we'll do integration first. To do integration, remember you need to put your limit here, your upper limit and lower limit. As I mentioned here, it's always up limit with your lower limit. Okay. So why I put up limit over lower limit, I already mentioned to you earlier, we are taking the larger one minus the smaller one to get this shaded. I repeat again, we take the large minus the small one, will get the lower limit here. So because some of you might ask me, sir, why not I put 2 and 3? Why I must put 3 and 2? Like I said, we take larger minus the smaller. So limit will be 3, 2, and you put your equation here, x square. We integrate with respect to x. Okay, you know why we integrate with respect to x, right? Because we looking the curve bounded by the x-axis. So now I'll further proceed, x cubed over 3, and I will put a limit here, 3 and 2. Okay, once I'm done with this part, I can just sub my figure inside. Okay, 3. Minus. Remember, I think this one Miss Catherine covered with you already, right? It's minus, right? Always. Let me just flip through the textbook. I'm not sure whether it's already covered or not. Yep. Somewhere there covered already. See, minus. Yeah. Okay. So this part you should know lah. Okay. So it's minus. Okay. So here is 27 over 3 minus 8 over 3, and then you will get 1 over 3. Okay. So that's all. So what's the unit? It's units only. So I want to explain something in detail here. You must remember, area is always positive, cannot be negative. So that means what if you calculate, somehow you calculate and then you get negative. So when you get negative, we will change it to positive. Okay. You might be wondering how I know this. You see they mention here, they say for region lie below the x-axis, the area is given as this thing. You know what this thing is, right? This thing is known as the modulus. Modulus means all negative value we will convert to become positive. Because why? Area cannot exist as negative, it's always positive. So take note of this. Later we'll do one question, I'll see then there's one question here, later we do this. Okay, so if you get negative, you auto convert it. Okay, that's the limitation of integration Okay, so that's work example 1. Now I'll do work example 2 with you. Okay, so for work example 2, I need to zoom out first. Okay, please video, don't stop. I swear I'll slap you video. Okay, so now this example here. Okay, I hope you can see this example here. Okay, I'll write down here. So y equals to 1 plus exponential 1 over 2x. Okay, so they already draw the curve for you here. Okay, this is exponential. Sorry, it's a bit off here. So 1 and 3, blah blah blah. Okay, so y, this is the equation e 1 over 2 x. Okay, so they want to find the as usual at here, this bounded region. So you need to integrate lower limit, upper limit. So what's our upper limit? 3, lower limit is 1. Okay, I repeat again, because we take the larger one minus the small one. Okay, that means we take the larger one minus the small one to get this shaded region. So our equation will be 1 plus exponential 1 over 2x dx. You know why we put dx, right? Because we are talking about area bounded by the x-axis. Okay, so I'm just going to skip through this part for you, because I assume you already know how to integrate this. So x, and then here I don't want to skip because I don't want to make the video too lengthy and so and forth. Okay, so once you reach here, you integrate this, you get this. Then what you do? You sub the value inside here. Okay, So I'm just going to sub the value here, 3 plus 2e 1 over 2, oh crap, 3, sorry, minus, okay, 1 plus 2 e 1 over 2 and then 1 here, okay. So you press in calculator, you will get your answer as what they write here, 7.67. So some of you will be asking, sir, they put in the set forms, do I need to put it? No need lah, we just put in 7.6 form Kennedy, okay, it's not really that important. So that's one example there, and then we will cover the next example here, okay, this question here, okay. So this question is a bit interesting. Actually this question is also not that hard lah. The best question is I think the last question, okay. I need to draw first, so give me some movement area here. I'll just move here, okay. So curve is here, okay, so I have something like that, okay. So imagine 0, sorry, my drawing off a bit already. So y equals to x square minus 3x here, okay. So now I want to find the area bounded by the curve here. As I mentioned, we must take the big minus the small here, okay. So upper limit, lower limit. So I'm going to put here 3 and 0. Equation be x square minus 3x dx, okay, because bounded by the dx, okay. So some of you may be wondering, so why not we look at it down here? I already told you, we want to look the area where it's trapped between the curve and the axis. I repeat again, we want to look at area which is trapped between the curve and the x-axis. Like for this example also, we are looking for the area that is trapped between the curve and the x-axis, okay. So don't come and tell me that we are looking the area at the bottom here. No, okay, we are looking at the area trapped with the curve and the x-axis. So I'll proceed my integration here. So x cubed over 3 minus 3x square over 2, and then I'll put here 3 and 0, okay. So now what I will do, I'm going to just sub inside lah. 3 cubed minus 3 3 square over 2, okay, minus, I think the 0 we can skip. You know why we can skip, right? Because you put all 0 going to be 0, so don't waste your time computing there. So after you calculate, I think here is 3 cubed 27 over 3, 27 over 3, which is 9 minus, or you should get negative, okay. So I just refer to your textbook, you get negative 4.5. As I mentioned earlier, when you get negative 4.5, what does that mean? That means you need to convert to positive, because area cannot be what we call that, negative, right? So you just convert by yourself. You can put a modulus there, unit, okay. So this is how we do how to find the integration, I mean the area under the curve through integration lah. Okay, so now we go to the last part for the exercise for the day, okay. Right, okay. So this one will take a bit time lah. I just want to draw here, okay. So okay, actually always remember, trigonometric function will really give you a hell of a time, okay, usually okay. So y equals to 2 sin x, and then they want only the area up to 3 pi over 2, okay. So they want the area up to here only, they don't want up to anywhere, okay. You see you have two different area bounded, okay. So there's 0 here, there's pi here, okay. Some student will think, okay, sorry for my bad drawing, maybe I'll just use the textbook and then do working here. If you see, the area is actually from 0 to pi to 3 pi over 2, okay. So we are looking at this blue color area, this red color area. Some of you think, can I put my limit like this or not? That means the question already said find the total area of the shaded region. So when you see area, you might be thinking, okay, let me just zoom for you. I can't zoom.